Hi friends, in this video we'll see the practical implementation of simple linear regression with a small data set and how to calculate the linear regression model by calculating the slope and intercept, and how to analyze the performance metrics of the linear regression model, and followed by how you can use the scikit library which having a machine learning built-in models. Using that, how you can develop the linear regression model. So first we will do how to use the manual computation of the linear regression model by knowing the formulas, with the slope, intercept, and by using the equation y is equal to b0 plus b1x. And now to do this, first you need to import the necessary libraries. So first I will import NumPy as NP, and next I need to plot it. So I need a plot, import matplotlib dot pyplot as plt, and these two basic libraries. First I will use it and I will execute it. Yes. So now this is my data. So I have a height in the independent variable and weight is the dependent variable. How the height impact the weight? So using this input data, we need to develop our linear regression model. So this is my data, and then I need to know how the data are scattered. So by using the scatter plot, x and y, we have scattered the data. So how x-axis your height and the y-axis is the weight. And using this input data, we need to develop the linear regression model. To compute the linear regression model, we need to calculate the b0 and b1, that is the slope and the intercept. b1 is the slope and the b0 is the intercept. b1 is otherwise called as regression coefficient. And now to work with this array of data, that is the list of data, need to be converted as a NumPy array. So I need to convert it. X is equal to NumPy array, and same that I need to convert the Y array. So my arrays are ready with NumPy. Next step, you need to calculate the mean of the data. Since you know in the formula, you need to calculate the mean. So to calculate the mean, I need to use with x is equal to mean of x is equal to np dot mean of x. Same thing, mean of y is equal to np dot mean of y. So the mean values are ready. Next, you need to calculate the cross deviation, that is this x minus x bar, y minus y bar, and also you need to calculate the deviation of x, that is the variance of x minus x bar the whole square. So to calculate it, first I need to calculate x minus x bar. So I am using x minus x bar, then y minus y bar, y minus y bar. After doing that, I need to calculate the multiplication of both the things. So I need to use with xy is equal to xx into yy. Next, followed by, you need to calculate the x minus x bar. We already calculated. You need to take a square of it. So I need to use with equal to square of. Okay, so now it is ready. So all the components needed for the formula is ready. So the above is the cross deviation, that is the between the x and the y. So we need to multiply that. xy is equal to, I need to do with sum of xy because it is a summation. We have calculated this multiplication, now we need to calculate the summation of it. So same thing, the deviation, that is the variance of x, that we need to calculate with xx is equal to sum of xx2. So both are ready. Now you need to go with the regression coefficients. Regression coefficient represents this b1 and b0. So the formula for b1 we calculated with ss underscore xy divided by ss underscore xx. Okay, so xy divided by this xx. So that is ready. Then we calculate the next coefficient b0. b0 is equal to the formula, that is the mean of y minus b1 into mean of x. So mean of y is available in y minus b1 into mean of x. Now you need to print both the things. You need to print it. Print first one is the slope, that you have the value is b1, then intercept, that you have a value is b0. So now we will execute this. It's calculated, and regression coefficient, yes. So our slope is ready and the intercept is ready. So based on this regression model, so now we formulated y is equal to b0 plus b1x. Using this, you need to now predict. So we have a set of input x. For that, we need to predict what will be the output. So y prediction is equal to b0 value know it plus b1 into x. So this will help you to predict the output variable. So we have predicted it based on the linear regression model. And now we need to plot it. So already you plotted your xy points. And now we have got the prediction line, that is based on your b0 and b1. We got a regression line. So that I am going to plot the x and the predicted line, that is in the green color. And the x label I am going to use with height, and in the y label it is weight, since our input is height and the weight. So you need to show the plot. Yes, so actually only one data is exactly fitted in the line. Remaining all data points are deviated from our linear regression model. So you need to find out what is the error between your original data and the predicted value. So error is computed as error is equal to y minus y predicted. So that I need to print it so that I can able to know what is the error level. Yes, so I have some errors. Okay, this is only almost near to it, but remaining all values, it is deviating from your linear line. Okay, that is your regression line. So based on the error, I need to analyze the performance of my linear model. So next, I need to calculate the performance analysis in terms of mean absolute error, mean squared error, root mean square error, and R2 score. So to have these performance analysis, the functionality for these analysis are already built in a library called as scikit. So we need to import it, sklearn.metrics import mean absolute error, then mean squared error, then followed by R2 score. So in order to calculate the root mean square, you need to import the math library. So that also added. So first I need to calculate the mean absolute error. Mean absolute error. So we need to pass two information for the mean absolute error. You need to pass the y value and the y predicted. Same thing we need to use with mean squared error. Mean squared error is mean underscore squared error. There also I need to pass my y value and the y predicted value. Followed by I need to calculate the root mean square. So print RMSE in the math dot square root. You need to pass the mean square error. So mean square error is ready. Root mean square error. Last one is R2 square. R2 score that you need to calculate with R2 underscore score. There also you need to pass y value and the y predicted value. So now we will run it. Yes, so we got all our performance analysis, mean absolute error, mean square error, root mean square and the R2 score. So instead of doing manually to calculate with B0, B1 and then predicting the y bar value, in the scikit library itself we are having the packages which will support the machine learning algorithm. To create the linear regression model, we have the scikit library that will support the various machine learning algorithms built in. So to work with this linear regression model, first you need to import the scikit library sklearn dot linear underscore model import linear regression. Okay, so this model get loaded, our linear regression model library got loaded. So this linear regression model, you need to give the input as a two-dimensional array, but now we have a 1D array for x and y, so that you need to reshape it first. So I am going to do with np dot array the input. I am going to reshape it. So this reshape function will create x as a 2D array. So we want to display and check. Okay, it will be created as a 2D array. And like that I need to repeat for y. Y is equal to np array. So my data got prepared. So instead of doing all manual calculation, calculating the mean, then calculating the difference between multiplying it. So in order to avoid all those things, our machine learning library will provide very simple thing. We just import the linear regression model and you pass your x and y, that automatically create you the linear regression line by internally calculating the B0 and the B1. Instead of doing that, in order to do that, you will use with, you create one model name, there you call the linear regression. So this will initialize your model, and in this model, now the model name is estimation, EST. In that, you need to do a training. In order to do the training, you have a function called as fit. You need to pass your inputs x and y. So your model get learned and your B0 and B1 is learned from your available x and y. So you got a model ready which is trained with x and y. So you need to just display what is our B0 and what is our B1. So to do that, I am going to use with printf and my slope, that is nothing but in the model I need to call with coefficient underscore. So that will give me my slope. And then printf, I need to get the intercept. So that will be available in estimation dot intercept. Now that also ready, you execute it. So here it is print, it's not printf. Sorry. You have your slope and intercept. So what you manually calculated here, okay, what you manually calculated step by step, the same thing with the use of this machine learning library scikit, we are easily doing within 4 lines. Okay, so now in order to do the prediction also, we have a function in the estimate itself called as predict. So for which input you want to predict, this is the x input, I need to predict it. So I create my prediction variable. So based on my input, I got my predicted output. Yes, it got predicted, and you want to calculate the error, you just print your y value, that is your capital Y, minus your predicted value. So that will print you the errors. So you calculated here. This is your error. The same thing you calculated your predicted error. So now you want to plot it. Our input is x, our output is y. Again the regression line you need to plot. Our input is x and our predicted is y predicted. So we'll execute it. Yes, so whatever you did with manually to do the linear regression and calculating the slope and intercept, now using the scikit library, it is very easy just to use the linear regression model. Using the function fit, it will train your model. Using the function predict, it will predict when you give an input, it will get the prediction based on the learned model. So you need to calculate the performance metrics. So while I execute, I will get my performance metrics, same as my absolute error, squared error, mean squared error, and the variance score. So this video, I think it helps you to implement your linear regression model for a small data set, how you can calculate your simple linear regression by manually, and also how to use with the scikit library to work with the simple linear regression. Thank you.